Bismillah Rahman Rahim. Welcome to my channel Learn Math with Sayyid Ali. So I have got two questions for radical math from one of my remote student. So we will see how can we make use of our radical formulas which we did in the lecture 1, right? So this is lecture 2 for radical math. Solve the following. Question number 1 is two brackets are there and they are multiplying. So we do the same thing as we do in algebra. Like the first term goes and hit the second bracket or multiply with the second bracket, and the second term then goes and multiply with the second bracket. So how can we write? We can write when this go and multiply with the second bracket, we got 4 cube root of x, right? This multiplied by with this, and then minus sign. This multiplied by this means I have to keep them separate because the radicand is different, right? So we, for a while we will put, but the indices is same, so we can have a solution for that, we know. So in the next step we can do the solution. We can make it x cube, right? Because the radicand is different but the index is same, right? So we can multiply them. That is the rule. And then the second term goes in hit or multiply with the first term. So 4 to the 8 cube root of x square, right? So cube root of x square, and then this term multiply by this term. I will write it here. So minus 2 cube root of x square times cube root again of x square. Again we can do the rule here because we have the same in this index and we have the same radicand, right? So we will see, we will make it x power 4 definitely, and we will do the addition, the simple. So 4 is outside, so we have this remaining 4 cube root of x minus, we can do here that these are same, right? So we can say x times x square because the index is same, so I can keep index as here and multiply the radicand, so I have x cube. So you have to follow the rules, right? Plus 8, that remains same, so I am just copying down here. But here I can do something. What? That is, I can write radicand is x square and the index is 3. So I can multiply that radicand, which is x power 4, right? So now we can see what we can do here. So 4 cube root of x remains same. I cannot solve it further. Minus cube root of x cube I can solve because x cube and the cube root gives you x. So I can write x plus, now I have 8 and cube root of x square, which I cannot do right now because it's a cube root of x square. Cannot do anything with the cube root of x square. Minus, I can rewrite this as cube root of x cube and another x, right? Another x. So I break this x power 4 as cube root of x cube and x, right? Cube root of x cube and x. Of course, I can solve x cube and the index is 3. So my result is again x, right? And here I cannot solve it further. So that will remain under root x, right? So under root x, if you multiply under root x with this, it will be x power 4, right? So I have 4 cube root of x minus x plus 8 cube root of x square, cube root of x square minus, what I can do is I can solve this thing which is giving me x, right? Cube root of x cube is x, so I have 2x and under root x, right? Cube root of under root x square or cube root of under root x I cannot solve further. So here is also cube root of under root x. you can take common between these two, because cube root of under root x and cube root of under root x, you can put like this, 4, so under root, so I can say, but in the simplified form you can leave it here maybe, or you can do one more step, that you can take common this and this. In most of the textbook it is written like this, but if you want to take common, but it will be complicated because you have to expand it in a simplified form. So this is what we got. So here we multiply, right? This in the same way as we multiply a plus b with a minus b, right? So what we do here, a plus b, a minus b, a times a, right? A goes and multiply with the second bracket, right? And then b goes and then multiply with the second bracket. The same thing we did here, but we have to take care of in the next step that what can be added or subtracted, right? So we did all what we can do for this simplification.